I'm Anil Kumar, sharing with you a test paper on functions. Question number 1 here is, what is domain and range of the following functions? We are given three parts. A relation between x and y that consists of all points xy such that y is positive and the distance from xy to the origin is 4. Part B is f of x equals to x squared minus 6x plus 8, and part C is a piecewise function g of x equals to x minus 1 when x is less than minus 3, g of x is equal to x squared minus 2 when x is greater than or equal to minus 3 and less than 1, and x is equal to minus 3 for x greater than 3. You can pause the video, answer the question, and then look into my suggestions. Let's solve part A of this question first. We are given a relation between x and y that consists of all points xy such that y is positive and the distance from xy to the origin is 4. So what type of function is this? Let me sketch a graph here, small, to understand what we are talking about. So on this coordinate plane, we have combination of this point xy so that y is positive and distance of this point xy is 4 units from origin. So from origin, you are 4 units away. So it's like a semicircle. Do you see that? So this is minus 4, this is plus 4, and the y-intercept will also be plus. So a semicircle is the one which we are talking about in this description. And now clearly you can write domain and range, right? So in this case, domain of the function could be written as from minus 4 to 4, right? And the range can be written as from 0 to 4, correct? So we have used interval notation to write down this answer. Part B is f of x equals to x squared minus 6x plus 8. This is a parabola. It opens upwards. We need to find the vertex, correct? So that we can find the minimum and then write the range. Domain is, of course, all real numbers. So we can do completing the squares. So we could write this as f of x equal to x squared minus 6x. Half of 6 is 3, so we can add and subtract 3 squared. That gives us x squared. Okay, so what we can do is we can actually save a step. We can take the first 3 terms and write this as x minus 3 whole square, right? Minus 3 squares minus 9 plus 8. And that gives us x minus 3 whole square minus 9 plus 8 is minus 1. Now from here we can write domain and range. So for part B, domain is all real numbers, so which we could write from minus infinity to plus infinity, and the range in this case will be y value being greater than equal to minus 1. So it's from minus 1 to infinity, correct? Now let's look into the piecewise function. It's better to sketch the piecewise function to clearly find domain and range. So we'll just make a small graph here. We're talking about g of x, which is a linear function when x is less than minus 3. So let me create a grid here. Let's say, okay, minus 1, minus 2, minus 3, minus 4, minus 5. On the positive side, we are going up to greater than 3. So let's go 1, 2, 3, 4, and 5. And let's just make some values here. 1, 2, 3, 4, 5, 6. Okay. And some values here. 1, 2, 3, 4, 5. Okay, let's try to see. Now, when x is less than -3, that means -1, -2, -3, this place, it's a linear function. So if I substitute -3 here, I get -4. So I could come down 1, 2, 3, 4. So that enters a hole since it is less than, right? And if I write -4, I get -5. It's a linear function, line like this. Slope is positive x, right? So this is -4 for us. Part B is a quadratic function, parabola, from -3 to 1, x squared -2, right? So this is a parabola which opens upwards. If I substitute -3 here, so this is -3 for us. If I substitute -3, I will get -3 squared, which is 9. -2 is 7, so we get 7 here. So 1, 2, 3, 4, 5, 6, so right here, okay. And that point is included, so let me make a solid hole. Filled in circle. If I substitute 1 here, I get 1 square -2. 1 minus 2 is -1. So at 1 I get -1. But this is not included, so I make a hole here, okay. However, if I put 0 here, I get -2. So I have a minimum at -2. So it's a parabola which is kind of like this. Do you see that? Where this point is at 7, right? Let me write in a different thing, which is this point is -3, 7. Okay. Now the third part is when x is equals to -3 for x greater than 3. So this is 1, this is 2, this is 3. It is -3, not included. So it's kind of like, do you see that? So that becomes the piecewise function. Now from here, you need to write domain and range. Clearly, as far as the domain is concerned, we do see a discontinuity here, that x is not equal to this interval. So we could write this as domain for this function as less than -1, correct? So that is, say, -infinity to -1 union, and then from and then from 3 onwards, right? I mean, sorry, it's +1. This point is 1. So less than -3, -3 to 1, -3 included. So, and then, so up to 1 we have this, and then we have greater than 3, not equal to, so from 3 to infinity. So that becomes the domain. As far as the range is concerned, it is less than -4, so we can write this as from -infinity to -4. It is equal to 3, and it is between -2 to 7, right? So it is between -2 included and 7 also included, right? 7 also included. So that's kind of tricky. So that becomes the range for this function, right? So from here to there, correct? So that is how you could write domain and range for functions. I've taken different kind of examples here to prepare you for your own test. I'm Anil Kumar, and I hope you appreciate it. You can always like and share my videos. Feel free to post questions and share your test papers. Thank you, and all the best.